official. I can just read off the slides too, that's even better. Okay. All right, well, now the intro slide is up, and now the doors are closed. So we can go ahead and get started here, and I'm sure more folks will be trickling in from lunch over the next while here. This panel follows in the traditions of the others that will come before and will come after it as well, in terms of having a wonderful, distinguished, and diverse group of panelists up here. And I'm delighted to have all of them here who have traveled from some distance to be with us today. I've been casually talking about the concept of zero-trust networking at CENIC for a while, in board meetings and board retreats. I dropped some hints about it at the CENIC conference last summer as well, and I finally decided it was time to run a panel on the concept, and so here we are. The five folks that I have to my right here are here to discuss the problem with all of us. I'd first like to introduce Barclay Osborn, who's a site reliability engineering manager at Google, who's at Google has developed a technique or set of technology, some combination of the two, which is known colloquially, I guess, as Beyond Corp. And so Barclay is going to give us a little bit of an introduction to that. Brooks Evans is a director of security at Netflix and is going to be talking about Netflix's own instantiation of zero-trust networking, which I think is called Lisa these days. Yes? Okay. Also with us today is David Thurston, who's the Chief Technology Officer for the San Bernardino Superintendent of Schools. And David is here with us to also try and address really what are the problems that K12 schools are facing as well. So we're really looking forward to your perspective on that. Michael Liang, the Chief Information Officer for the San Francisco Public Library, is here with us today, also looking at a significant portion of what is the problem we're trying to solve. And finally, David Rusting, the Chief Information Security Officer from the UC Office of the President, who is going to be coming at this from both sides and has implemented zero-trust networking in the past and is also able to offer his own perspective on the challenges that the UCs face for security as well, and the ways in which zero-trust networking can address that. So this is really designed to be a panel in the true sense, because we have folks that are providing expertise on both the problems we're trying to solve as well as solutions to try to solve them. It is also designed to be a panel inclusive of the audience as well, and so we have certain questions for the audience that we are going to be tossing out to you, which the panel will field. And so this is not going to be a presentation-heavy next hour together. That being said, there are some basic concepts about zero-trust networking that I think will help set the tone for this discussion. And so we will begin with that. And so I'd like to give the stage over for the next, 5 to 7 minutes or so to Barclay here, who will be followed by Brooks.
Hello. This is going to be challenging. It's normally an hour talk that I'm trying to do in 5 minutes. So it'll be a little bit cursory, but also I'm highly caffeinated, so I have faith. Beyond Corp, for those that may be visually impaired, to improve security by granting Googlers access to services and tools based on what is known about them and their device, not the physical or logical location that they're connecting to. So every Google employee should be able to work unsuccessfully from untrusted networks without using a VPN. We usually call this the Starbucks office. Working from Starbucks. So the super long TLDR, how do we want to grant access? Is it you? Are you present? And can your device log? Those are the three main questions. So not are you physically on the premises, are you physically connected to an Ethernet switch or within range of our access points, or not logically on premises, or like a VPN essentially would bridge you into your internal network. So how do we do that? I don't know, can you read this? Quick overview. On the left, the yellow are essentially data sources. These could be things like mobile device management agents. They could be prescribed data like assigning an asset number to some inventory system. There's observed and prescribed being the two main categories. Those are all aggregated into this thing in the middle, in the blue, called our device inventory service, which says maybe take some data from an MDM and something from like an asset management says these are the same device. We also have something that evaluates all these facts and says, how much do I trust this device? And this is trying to answer the question, can your device lie? So it might be things like, is it running antivirus? Is it encrypted? Is root login enabled, et cetera, et cetera. We look at hundreds, if not thousands of facts like this. That's fed into, back into this inventory of devices. And we have all these gateways and resources on the right in the purple that access an oracle, that access control engine that takes your policy, takes all these devices about, facts about your devices, like we think this is very trusted or not very trusted, and sort of gives it a score. You could call this risk-based authorization as well. On the right, the outcome might be, yes, you can contact this web resource, and that may be very granular, like, oh, I can read a bug, but I can't update it or close it. Or it could be like, I'm going to assign you to this particular VLAN, I being radius. Sorry, moving really fast. So authorizing proxies, normally there's a couple evolutionary slides here to get to this one. Notably that things are more interconnected in the earlier slides. And in the later slide, you can see you can't get one from one privilege domain to a different privilege domain without going through an authorizing proxy. One of the questions that usually comes up is, what about peer-to-peer? If peer-to-peer is acceptable and the protocol is acceptable by policy, you can authorize the initial authorization authentication step, and that'll use that to open up the peer-to-peer communication later. That said, we don't do a huge amount of peer-to-peer. Tiered access. So notice that you usually get a authorization decision, yes, no. It's pretty binary. We want something a little bit more granular. On the left, right, the red or exclamation points are bad, question marks are sort of middling, and check marks are good. On the greatest right, you can see that the user has authenticated, and we believe this device is in a good state as per our policy, greatest amount of trust. There's some middling areas though where maybe it's orange or yellow and you're still authenticated, but we don't trust your device quite as much for whatever reason. Maybe it's we don't control some portion of the stack. Maybe it's because there is currently a 0-day exploit out there for this particular revision. So we can adjust dynamically there and say, well, yes, you can review that change list or that pull request, but you can't approve it for submission. All the way down to the, we believe you're compromised and we're just going to brick your device if possible. So, whew, that was really fast. How can I implement it? Sorry, this is the obligatory, use Google Cloud platform for your stuff, or you can roll your own. And I'm sure that you'll get some different perspectives from other people on exactly how that might work. Did I hit my 5 minutes? All right. And Brooks.
Okay, again, probably 5 minutes, we'll see. I just want to hit some of the differences between Google's implementation and really how Netflix got there. If you look at what we have today, it's very, very similar, but if you step back maybe a year and a half, 2 years, there were quite a few differences in how we started to approach Beyond Corp. So first in name, we do call our implementation LISA, Location Independent Security Approach. And like everything at Netflix, we have a logo for it, although quite abstract. So what is LISA? Certainly the security architecture of ZeroTrust networks, really about stopping trusting our network location. Also learning how to get really good at authenticating users and making sure their devices are healthy. And so that it shares a lot with Google's implementation. Why? So anyone who plugs into our network can have access to sensitive services. 3 years ago, if you walked into Netflix and you plugged in, you could absolutely get access to stuff that most people in the public shouldn't have access to. But we really wanted to maintain freedom of movement through our facilities. So if you visit one of our buildings, you'll find it more like a college campus than it is like a corporate office. So you don't see people wearing badges, you don't see a lot of locked doors. You have the ability pretty much to walk through most of our campus as a member of the public and plug in if you want. But the other side of that is we were also becoming a very global company, and we realized we had a lot of employees who never really saw a corporate office. So they needed to be able to work very effectively from that coffee shop model, where they would never sit behind a network that had trusted access. So in enforcing the zero trust model, we also got all of our services to a place where people could use them from anywhere. And then, as it says here, to accelerate the death of the perimeter, really is understanding that a lot of our threats were coming from inside of our walls, not really coming from out of the internet. So the benefits, we reduced attack surface, certainly man-in-the-middle attacks, types of things that happen inside the building very effectively. It stopped the majority of those. It also stopped some of that peer-to-peer stuff that we actually needed and then learned about afterwards and had to figure out how to work through. It also became our choke point for authentication, access control, and inspecting the end user and the device to make sure that they're healthy, and it allowed us to do endpoint checking. So much simplified network architecture, certainly cheaper equipment in most of our buildings, allowed people to use it in and out of the office, certainly saved us a lot in cost once we were over the initial hump of the change. And then I would say that little custom development, I'll touch on one of those here in a moment. And then we weren't really tied to a set of supported vendors. We've swapped out networking vendors several times in the last few years, and we even have multiple different types of networks in various facilities. They all seem to work with the model. Endpoint checks is something that Google also does. We actually open sourced a tool called Stethoscope that you can check out. We had moved away from systems management about the same time we started working on Lisa. So we needed a way to assess the health of devices without having some sort of root access to everyone's device. Just a quick plug, an example of our Stethoscope tool, which checks all the health on a device. It's very configurable. For us, we have a few things like disk encryption, antivirus, firewall, things like that. And if you don't have all these things, you'll turn yellow or it'll turn red and you won't get access to as much stuff, as many services. In general, to get to where we were with Zero Trust or where we are today, very much like Google with a proxy type approach, we had a VPN at the moment. We moved into VPN, we put everything behind it, and we deprivileged all the local networks. So VPN became kind of the bridge to get us to this model. Device isolation, certainly you can't talk to other devices in the building. No communication from one device to another device. And then pretty much had to jump on VPN before you could get into our cloud in AWS or into our data centers. Last slide, just a quick explanation. On the left is the Lisa network with a normal workstation accessing the internet, accessing VPN, and getting into our data center. The device on the Lisa network is just an important call out that we have a lot of devices at Netflix we test for stuff like televisions and things that people watch movies and TV shows on. So our data center, AWS clouds are able to reach into the building and touch those. On the right-hand side is just acknowledgement that, yeah, there's always going to be networks that don't work in this model. There are still locked doors at Netflix with lots of equipment behind them that need direct access into our data centers, and those don't fit in this model. So there are exceptions, and I just like to call that out.
Okay, Barclay and Brooks, thank you so much for describing those architectures. That really sets the stage incredibly well. That's fantastic. Location-independent security architecture, protecting against threats from inside. Is it you? Are you present? Can your device lie? I mean, these are some really interesting and fundamental questions to securing our networks, and I think we can often lose sight of some of these things, some of these relatively basic and foundational things in our insistence to buy devices and put them on the network and have them scan traffic in certain ways and try and refine whether we've captured every piece of malware on the network. And this is a very different approach to that in many ways. I'd like to flip over to some of the folks who can help us understand the problems that the networks in research and education environments face a little bit. So in particular, I'm gonna turn to David Thurston from San Bernardino County and to Michael Liang from San Francisco Public Library. Threats from inside, that never happens to you guys, right? I'm curious, maybe in your own words in a few minutes, if you can help us understand a little bit what the key security problems are that your institutions face. And in parallel, and this is sort of the second part of the question, is what is the perception of the security problems that your institutions face by the people who might patronize your institution? So at a library, Are people scared to death to touch your Wi-Fi because they're worried about getting malware in the same way that we don't connect to hotel networks, maybe a similar question for Dave about students and parents on school networks as well. Who would like to go first?
I can go first. At libraries, most libraries, including San Francisco, is about freedom of access and freedom of information. So the public hopefully feels confident that if they use the technology at the library, it's safe, but it is open. We try to educate the public and warn them of security concerns and issues. However, we try to put our own protection on devices, but we have a splash screen that tells them, be very careful what you do, because it is a very open network. I use the word open more, but it's really almost dirty network, and we do isolate that network as much as possible.
So in the K-12 space, I think there's a dynamic tension between your back office mission critical business applications that are necessary to keep the doors open and the district's functional, and then the classrooms, which are typically ideally treated like home networks, fairly open. I hear a lot of talk about either blocking peer-to-peer or somehow minimizing it. And we have devices in there, CAS-based devices from Google and Chromebooks that by default only use peer-to-peer or leverage peer-to-peer to operate more efficiently. So we have this dynamic tension in school districts where we really want to have a high degree of security in our back-end operations, but in that classroom, we want to at least give the appearance and the general day-to-day functionality of an open network. And so the zero trust model makes a lot of sense to me, although balancing some of the technologies to get there, what's essentially being described, and I don't mean to minimize this, but in my mind I go, oh, it's a NAC, right? It's a network access control solution that does some type of interrogation, both device and identity. And the challenges we have is implementing those across multiple device types that are inconsistently controlled and in environments that are both open in some ways and then very closed off in some other ways.
And what are the problems that you're really trying to solve in your day-to-day environment? And so, Michael, you mentioned you warn people that there's limits as to what you can provide on the library network, and at the same time, you have responsibilities to make sure the library is actually functioning. So, what is the security problems that keep you up at night, or that eat up your budget, or whatever they happen to be?
That's a tough question. Our devices are protected for them between patrons. We wipe them as much as possible. However, once it's open to a patron, they can do anything they want to do, which is a very scary thought. We don't monitor them. We don't scan them. We're not law enforcement. They want to do bad things, they can, because that's the freedom we have. However, we do our best to protect our network, our infrastructure. And you might say it's really an informed risk for the libraries to do at what level of security we want to put in place.
So in the K-12 space, I mean, that keeps me up at night is, a mass data breach, right? Either of student data, staff data, or financial data that we collect, for a public sector institution, a school district of, say, 20,000 students and 2,000 employees. We have a lot of information, right? That's just one example of an average school district in my county. We collect a lot of information. We retain it near indefinitely. So data breaches are really consequential to my mind, and so protecting that data, archiving that data, protecting it, and allowing access on a role-based premise, right? So interrogating the user to make sure that they have the access necessary. There's people spend a lot of time, a lot of money, at limited resources, because security is always an afterthought, unfortunately, in the public sector. In K-12, at least, it can be an afterthought. Limited resources in protecting those, and oftentimes they're done with middling effects, right? Either frustrating to our users to the degree that they can't access that data and those platforms as quickly as they'd like, or less secure than the administrators and the people in the know would prefer.
Makes sense. But let me turn it over to David Rusting, who again is the CISO at University of California Office of the President, and has implemented Zero Trust Networking in his past as well. And so I'm curious, David, so you've heard a little bit about the problems that Michael and Dave have described. what are some of the problems that you tried to address with Zero Trust Networking? Which of those did it address? Which of those didn't it address? And where did it actually create new problems? And just referring to Dave's comment a moment ago here, where sometimes security mitigations end up frustrating people.
Yeah, I mean, we are in an environment that's open by design, as folks have said, and if there's always this tension between being open and protecting the things that we need to protect that we're required to as good stewards, and allowing the innovation that the institution does. And so one of the challenges is there are still, I'll just step back and say it, at a cultural level, there's still conceptually challenges for not only our workforce members, but our leadership to actually understand going perimeterless. That having, not trusting inside the network. That still is a thing, even in this day and age. And the challenge is that, I'll give you a perfect example, right? Multi-factor authentication. Do you multi-factor people inside your building, or do you only do it when they're outside? This is actually a discussion point of experience. And I will come from perspective. I think it should be consistent in everywhere, because I don't trust any network. Any good security person shouldn't trust any network. And the only way you get to a trusted model is to do zero trust. So when we look at the solutions we put in place, part of it comes down to we are not a command and control environment. So the ability for us to manage devices or even have visibility into networks within our overall network is challenging. So we look at, from a risk-based perspective, which aspects of zero trust networking can we put in place? How do we educate very smart people about this and show that, one of the challenges we have is the sideways lateral movement within our networks is a number one risk point for us, because once people get in, they move sideways, and usually that's where there's open trust across the board. So what we've been trying to do is work with those researchers and other innovators to try to educate them on the dangers, but also, is there something we can do that has limited impact on their ability to do their work and innovate and work from anywhere they want? Because they do want that. They absolutely want that. But there's just this assumption that somehow that's going to make me protected. Or if I have a VPN, that somehow makes me protected, when in many cases, that isn't the case.
And when you implemented ZTN, then did you end up causing problems?
Anytime you put an additional security control on somebody, there's going to be some folks that complain about it. On the converse, for example, you put multi-factor in place, you put VLANs in place and VPNs that block folks out. We did this at University UCSF, where we had a protected network and we had a guest network. Ran the same pipe, logically bifurcated, and we fought many battles with people wanting to punch holes through that wall, and because they didn't want to actually have to log in. Seems silly, seems petty, but it's actually true, because when you make things easy, people want everything to be easy. And so that was the one thing in our environment, when we did our VLANs, when we did our divisions, we never crossed what I'll call the blood-brain barrier between something that was authenticated and non-authenticated. Now that was not, it's not as advanced as the zero trust stuff we're doing now. There's many platforms and solutions out there that help them. But from our point, we had to look at things that were very 5 steps away from the user, but we could get a reasonable level of trust between environments that we trusted and ones that we didn't, and then we would overlay other protections on top where we thought it would have the most bang for the buck from a risk perspective.
So I'm not going to turn to the audience for a minute. You've heard a description of the architecture. You've heard 3 different sets of problems, from a CIO who runs a library in which you can essentially control nothing about what's on your network other than wiping the devices that the patrons use on a periodic basis. From Dave, who is running security for a school system that has tens of thousands of school records that for which a breach would be catastrophic. To David Rusting, who has similar issues and is also trying to enable open inquiry and research on the University of California networks. Do some of these challenges resonate with the audience, or there's some others that you'd like to add? And I'm now going to wait for an uncomfortable pause while you answer. Or I'm going to start calling on people.
Sean, I can actually add something.
Yes, please, Dave.
So what I was thinking about these things, and at the K-12 environment and some of the other public sector environments, this is I think we're on the precipice of possibly bringing some relief to some degree, because a lot of the problem is the problem of scale. So if I have 20,000 students who regularly log on to devices at prescribed times, any NAC solution that I bring in is going to be fairly expensive and probably pretty intrusive to that process, and it's going to upset teachers who are political stakeholders who can derail a project pretty quickly, really, in a K-12 environment. And that's not to say that there are problem users; they have their own interests. But what I'm seeing, and I like what Barclay and Brooks, you mentioned your cloud-based solutions, and as school districts and some other public institutions at the County Office of Education migrate and start to explore cloud, we're latecomers to that. Typically, we're a little more conservative there. I could see, we're already leveraging Google's infrastructure. We're already leveraging some AWS. We could use that extra scale, so we don't have to make these large investments in proprietary on-premise systems, and also it minimizes the amount of staffing that we have, because we have such limitations in staffing. They're very talented people, but they don't necessarily have all the talent that maybe say Netflix or Google would have. I mean, those that you do have that talent.
Yeah,
really
I actually think it's on already. Yeah, you're good. I think you can just talk.
So interestingly, you can actually lean on cloud providers to be that proxy.
Exactly, that's my point. Yeah.
For example, my home network, I have some Nest cams. Those are on a separate VLAN, and they cannot talk to anything else on any other device at home. The only way it can actually contact that camera is I end up bouncing through Nest.com, which is essentially leveraging a cloud provider as a proxy.
Yeah, and those technologies aren't necessarily there for some of the casting we have to do in the classroom, things like that, because they'll slow down as a real-time video or semi-real-time video. But as we move more towards cloud infrastructure, and then I also like the idea personally of application delivery, and you can do this in the K-12 space a little better, I think, application delivery without OSs, right? So basically virtualizing your application library, putting it in the cloud, making sure that the security is role and authentication based as opposed to machine based. You can work from anywhere, essentially. It really creates some nice little not silos, if I would say, but it's isolation, but gives the appearance of perimeterless and like independent or location independent security.
I wrote down these bullet points that Barclay gave at the beginning. Is it you? Are you present? So we've heard a bit about identity here, and I think that's and access controls and authentication. That's certainly a big component of this. Can your device lie? Is an interesting, multifaceted question, I think, and cuts at, I think, one of the other points behind this architecture. So it seems to me that the fundamental component of this is protecting some sort of centralized resources of some kind. But this can your device lie really gets at another issue as well, which is the endpoint security as well. If your device can't lie, then I would argue that you've actually done a good job on securing the endpoint as well. This then gets to the question, is how do we answer this can your device lie kind of things, and what are the ways in which we can make it less likely that your device can lie? And so at least one of the questions I have really for the entire panel, whoever wants to take this one, is what role does simplifying the endpoint devices to make them less vulnerable to begin with have to play on this? And the reason why I asked this question is I certainly have many conversations with folks who say, I need Windows to do my job. And I say, well, what do you do? And they say, well, I use Word, Excel, PowerPoint, and a web browser. And I say, you just described a Chromebook. And you can throw that in a wood chipper and get another one the next day, and you've eliminated your desktop support for the most part. And I don't mean to sound more Chromebooks necessarily, but it could be iOS, whatever it's going to be. So somewhat simplified devices. What role does that have to play? And if it has a significant role, how do you get there? Who wants to take that one?
I'll take a start. Certainly at Netflix, one of the things that's allowed us to be, first of all, we're very device and OS independent, right? So we support pretty much every OS you can see, every OS that our customers use. However, when you start assessing health of devices, a super capable device, a device that can do a lot of things, like a Windows device, an iOS device, a Mac, the bar is a lot higher. Like it's a lot higher. We have a lot more demands on what that user has to do to keep that device in a healthy state. So a lot of times the users come to desktop support and they're like, wow, I have this problem. I don't know how to solve this on my laptop. They're like, oh, by the way, if we'll give you a Chromebook, that problem's solved because we've already put some guardrails around what you can do. and it allows that user to be more productive inside of that health check environment. So I would say that it actually kind of turned the tables for us and helped drive more people to the more, I would say, out-of-the-box managed tools like Chromebooks and things that are just certainly easier to secure from a consumer standpoint.
We've already been exploring this. Most school districts, not most, many school districts have invested heavily in Chromebooks, but they still have a need for Windows-based applications, and that's always problematic, right? So, we've looked at technologies like VMware's Horizons and obviously AppStream from AWS, and I'm sure Google has a version too that can leverage, mimicking that OS and those Windows applications in the browser. And therein lies your solution. You're basically turning a Chromebook into a VDI device to some degree, right? And delivering the app through the browser. Either that, or you're looking at containerizing your apps and then just publishing them on the web. It takes Windows or Mac OS out of the mix. I was thinking about that. Can your device lie? Well, if your device can run a hypervisor, then it can lie, right? So so if you can run VirtualBox, you log into your NAC, and if your NAC's not checking if VirtualBox is running in the background, sure, I'm okay. Now I'm going to fire up my VirtualBox, and I've got a full instance of Kali on your network. Well, it's mine eventually one of these days. So the idea of limiting the amount of OSs on a network, for me, works really well. It may not work really well in the UC Regent's office or the library.
But by the way, the answer to can your device lie is almost always yes. It's sort of like
All the time.
how easily, right? And then also in reference to something like, cryptographic checksums for presence indication.
Yeah, I would add, yes, devices can lie. They lie all the time. And I would argue that you really don't want to be trusting devices is like, to me, the last thing. It's really, to me, the intersection of it's who you are and some behavioral analytics, which all is a interesting topic to talk about. But there's a way to look at what is normalish behavior and what is significantly anomalous, and using that information to help drive decisions within access. And from a device perspective, we cannot control the devices. We can't control what people buy. They tend to migrate to what the market provides. So the big providers, that's great. It's really around being able to support those things. And there are these other ways that you get around providing the applications, as David mentioned. But to the end of the day, the device, we have to support almost anything that people bring to us, although there is a natural attrition in the market toward the main pieces there. And where locations want to have minimize their desktop support pieces, they tend to recommend things that require less support. But again, funding sources being multiple, people being able to do what they want, because we have very decentralized decision making, it creates an environment where you have to be very heterogeneous, and you cannot assume that will be able to control that device or manage it.
Michael?
With the library, libraries and librarians are there to help the public, and the public know that. And when the public comes to the library, you never know what to expect. They have a different kind of expectation at all levels, because we don't turn anyone away. We take care of the homeless, the elderly, the disabled, and sometimes those devices means complexity. We have patrons coming in with floppy drives, even expecting typewriters to be there. So it's kind of like an archive, a museum, a piece. We don't pretty much have all kind of technology to service the public, including Windows 95 still.
Although not in, so those are systems patrons are bringing in, not necessarily library systems for accessing library resources or payroll or HR or whatever, though, right?
That's right. I've only mentioned the public side. Now we have the government side. You might say my peers in other departments put firewalls against the library because they expect us to be very open, very kind of dirty. However, we are government. We have that government expectation, but even our librarians expect a certain level of openness, because if we're not open, then how do we service the public? That is a very challenge where we currently have two networks, and that could be solved by having a ZeroTrust network.
Well, in fact, you have services that cross that boundary too, right? And the patrons checking out books, you have to secure the heck out of that. I would assume.
Believe the library, at least in San Francisco, we are going toward a zero net, not knowing we're going there, just because of the services, our partners, our e-resource partners, and also the demand for cloud. And the expectation of the public was they are using Google Docs and O365, so it gets a little bit more complicated.
So clearly, this question, can your device lie, is a non-binary answer, right? Yes, but within shades of gray. And so clearly, this next question I'm going to pose to you is non-binary as well. But let me picture a plaintive fantasy picture for some of our constituents here. If you all have government-ish budgets that are relatively constrained, if you could get rid of 80% of the traditional desktop computers with devices for which it is harder to lie, and recapture that budget for other exciting sorts of things, wouldn't that be great? I mean, what would you do given that opportunity, or is that something that you could imagine doing in your organizations? You mentioned students are clearly using a lot of Chromebooks. What about the teachers? What about the administrators?
So it not necessarily my office because we're a COE, so we're a much more business-oriented function. But in the school district that I previously worked at, so 2 school districts I previously worked at, and all my peers who work in school districts are currently evaluating Chromebooks or iOS, specifically iOS devices, as alternatives for the standard teaching device. Now, there are certain back office functions that will probably always rely on either Windows or Mac OS, at least until the applications that they use are all web-based, which they're not all web-based. Thank you, terminal emulation. But I definitely see in the K12 environment that we're probably only a couple of years away from as some of our more veteran teachers age out, and teachers who are used to seeing Chromebooks or iOS devices as primary teaching devices will be more amenable to use those as their primary device. And so if that does free up the budget, I personally think that the next role is application virtualization, right? So you're not necessarily confined by the OS. That you can mimic that open kind of open application world on the web, and identity automation and better authentication. Some multi-factor authentication, preferably some kind of hardware authentication, because then you start to be able to really trust you are who you are. You say you are, and at that point in time, you really can offer up a platform on the web and not necessarily care what location they're from.
So Brooks and Barclay, I in contrast to maybe the UC, your environments probably are a bit more command and control in many ways, right? And so I'm curious, how have your organizations moved more towards hardened devices? That's not an easy thing to sell to organizations with lots and lots of engineers, right? And they want root on their machine or better. Maybe pull out a soldering iron and start going at the hardware. How do you encourage them to go towards a more secure option?
I think, at least in my environment, we are very, very open. Engineers can walk out, into any store and buy any tool they want to use to do their job. And we have to be able to support that. But as I kind of alluded to the Chromebook issue, where if you make the easy path the one that gets people to the most secure thing, then you take care of maybe 90 to 95% of the people in our buildings. And then we really focus on the 5% of exception cases, which are people that really legitimately need those other platforms to do their job. And that just allows us to focus those budgets and focus that effort where it really needs to go. Versus trying to, I would say, control the out-of-box experience that people get when they come in as a new employee.
Go ahead. There's a lot of concordance here, which leads me to believe that maybe we're on the right path. But I heartily endorse the idea that the easy path is what you need to execute well on, right? There's this thought that all security has a cost, and usually that's becomes an encumbrance on the user. It's something that they don't want to do, right? Which they'll work around, as several people talked about. So making that easy path the convenient one means that you're spending money elsewhere, right? To make that easy somehow. It might be that you're outsourcing to cloud, or you're using Chromebooks, which essentially is outsourcing that to Google, or it could be that you are doing something like we've instrumented our Windows, Mac, iOS, right, Android, all that are heavily tied down at endpoints, which means we put a bunch of money there that the user mostly doesn't see, and so the easy path is the way they take.
Okay, David, I'm curious. Is this an approach that University of California has tried to take at all, and what does that look like in your sorts of environments?
one, our environment, if you don't give people the easy path, they will find the easy path. I've seen amazing leaps that doctors have gone through in order to get around healthcare networks so they can get out to some critical application that they're needing to get access to. I think the most popular one is Fortnite today. But those sorts of things where they want to work around the system because the controls are very, they feel are draconian, but it's a limiting thing. And so it's absolutely right. I mean, the easier you make it, the more you funnel people toward that, you can focus your resources in other areas. I think the ongoing challenge in that is trying to figure out where is that balance where there's a risk, right? If somebody's doing open research, they feel like this is open, it doesn't matter. There's no security per se around it, except maybe like an availability issue. But the problem is they're working right next door to somebody who's doing something maybe more sensitive. And you can't trust your neighbors. It's kind of it's a weird thing because our culture is very trusting, very open, and very sharing. And so the ability to move toward a model where we're relying on we're able to trust the person and some other piece of factor along with them, with some device independence, but also again with some behavioral analytics, which we have. We have a very strong privacy ethos at UC, so we don't monitor and watch what people are doing, that sort of thing. But we do have to balance that with the facts that we get attacks from nation states and other criminal syndicates all the time that we need to try to prevent and reduce harm on. So it's a risk-based approach of where do you put the controls in and how do you make them as easy as possible for somebody without interrupting their ability to work or collaborate.
So let me toss another question out to the audience here. So you've heard a little bit at this point about what Google and Netflix have done in their corporate environment, what UC has done, what maybe San Francisco Public Libraries and San Bernardino schools are gradually shifting over to. I wonder if the audience has any thoughts on how this might or might not work in your own environments, and what variations would be have to put in place to make your environments function. Yes, sir. Oh yeah, we've got runners in the back of the room.
Thank you. Is it on?
Okay.
In the beginning, there was the talk about trying to not trust a network location. I'm curious if there's still value in having that as part of their identity, because I'm thinking for a lot of our authentication systems, the fact that an identity authenticates from a new autonomous system number, maybe there's some other network location, that's a flag saying that I trust, I have less level of assurance in that identity versus other ones. And so I still value that. I'm curious if that's a false value or if we should still hold on to that.
I think it's still a good signal. It's one you don't want to be completely dependent on. So one thing I glossed over is we have a set of facts that we pre-compute a priori about, say, an endpoint and say, we believe it can lie this much, right? But if it is coming from an embargo net block in the PRC at access time, right, because it's all proxied at access time, we might say, you know what, we're actually not going to allow this request through. So it is useful.
Or because you provide shades of gray of access, right? That seems to be a very important point as well. In fact,
Definitely.
I'm not sure what institution you're at, but we have plenty of R&E institutions that travel pretty internationally, and so perhaps those shades of access could be very important in those kinds of situations.
Yeah, I work for the CSU San Bernardino, and yes, we have faculty that they flag it because they're going international to whatever conference they happen to be, and it's the trust goes down, but it's one of those ones that's worth investigating a little bit further, and we're reactive in that case. It'll be flagged, it won't be blocked, and so it's worth the investigation at that point.
I would also add there's actually value to that. Let's take a health system or a medical center. Certain rooms, the security controls, you might have to have compensating controls where you trust more because it's that location, that device in that room. Because some of our traditional ways of doing extra authentication are burdensome in a healthcare environment, right? You have to find the balance between it. I mean, I can't tell you how many times people are like reaching over, tabbing their badge against something over and over again. They're going to get a neck strain. They're in the right place, but it's still that sort of thing where you have to find the balance. And I use the healthcare example as one, but you can find other ones where the location is actually a useful piece to know. It's just not I would not consider it the main piece. It's also a good, flag indicator, as I think you mentioned that, because it's like, I'm usually logging in from around here. If you find me logging in from overseas and you have confidence it's coming from overseas, you probably want to flag that because the users are the best feedback mechanism. Were you there? Yes. No. And they're much more aware. We have a culture. We try to make people question and raise things when they not only have a problem, but when we ask them, is everything okay?
Well, and also if you're doing behavioral analytics, like you talked about, location information is one more metric that you can use that does this fall within the profile?
Yep.
Right?
So I actually have a follow-up question maybe on this shades of gray thing as well. Do you have any other questions you want?
I just was going to thank you that, yes, there's still value in network location, and I got confirmation there, so thank you.
So, I think, there's a wide range of technical capabilities within CENIC's constituency and funding and resources and everything else. And I can imagine picturing the melange of criteria that go into factoring whether somebody should be trusted or their device should be trusted and the degrees of access that they should be granted, and thinking my organization can't do that. That sounds terrible, and it's going to be as complicated as calculating a credit score for someone or something like that. Granted, Netflix's and Google's exact weightings are presumably secret sauce, but what can you say about how hard or simple it is to sort of find the right levels for organizations like these?
We've taken a few years and worked on this, but I would say that the amount of investment, the amount of research we did, wasn't super significant in terms of dollars, in terms of engineers. It was really more about taking an hypothesis and really testing it and seeing whether it held true across our environment, and then storing that data, learning from it, and doing better. The other thing I would say really helped us was being able to partner with other people in our own industry and as well as others. So wherever we can, we've released the work we've done. We've released both the methodology as well as any code we've written. And we've really tried to get people to contribute back to that where possible, or to challenge that where possible, because that allowed us to reduce the cost for ourselves, but also to hopefully move the needle a little bit for the rest of the community. I would say that's really the balancing thing that helped us keep that cost down. So it's not really a budget item for my organization.
Yeah.
I'm struggling a little because I feel like it's kind of like find a solution to this in 5 minutes, which sounds tough. For us, the one of the most important things though was really the sort of the cost benefit analysis for what we were going to engage on. So one of the things we realized very, very early on is we actually didn't have nearly as good of an idea of what was on our networks, be it traffic or devices, as we thought we did. And it wasn't until we started investigating that a little bit further and saying like, oh, lateral movement is one of the number one techniques of APTs, advanced persistent threats. That's where we should focus minimizing, is lateral movement on our local networks. And then we grew out from there as that got resolved. So figure out what your what the most beneficial, like highest threat, lowest cost to address is.
I actually think it's pretty interesting because I see this move to zero trust actually being precipitated by the cost reduction in traffic and inspection and application identification, right? So it wasn't until school districts were able to introduce certain technologies, next generation firewalls, so they started to get an idea of what kind of traffic was on their network. I mean, a lot of times we were looking at just port 80 and port 443 just to say, okay, this is where they're going. But once we started to implement those type of technologies, and then maybe to some degree NAC, we were able to get a broader understanding of what was on our network. And at that point in time, I go, okay, how can we minimize their ability to move laterally? How can we minimize their ability to go? Well, in our case, we don't necessarily need them to go everywhere they want to go because sometimes they're not allowed to go there legally. But how can we kind of streamline that and make it less lower that threat threshold? And it's interesting because I think that the last 5 to maybe 10 years, 5 years probably in the K12 space, the costs have come down enough where we can get that insight and we can really start to kind of plan our zero trust or semi-zero trust implementations accordingly.
So for us, it was actually sort of figuring out what's on the network and then converging towards the zero trust was a function of deploying it seamlessly without impacting users, right? Like we could have definitely deployed it far earlier and we would have broken a lot.
Stuff. Yeah.
I was just going to add, I think the ability to correlate a device to a person is actually super valuable. If you tell people which devices they're using or that you think that they're using, not what they're doing with them, but that they're authenticating with them and so forth, that's a very useful thing because people kind of know what they're using. And again, it's about engaging them and being able to show that in an easy way, right? Looking at MAC address tables and trying to correlate them into whatever repository for data identity you have is one thing, but having that visible, which is something that it's I think a gap in the market to easily be able to show you that not only devices but the context related to that person is pretty key to helping understand again where the threat is and where you apply that piece. And again, each organization tends to be at a different level of maturity in those areas based on the type of work that they do.
I wonder, David, for someone who has now implemented this, I presume you've had this conversation with your R1 colleagues and the other UCs. What sort of advice would you give to your CSU friends within CENIC or K12 or libraries about starting down this path? Where do you start? What does it look like for a research and education organization?
Yeah, so I think to say that you've done it is all. You're never stopping doing it. You're always doing it. You're always trying to attempt to have this kind of security model. I think one thing you need to do is actually need to start at the top with your leadership a bit to make them understand what the risk is and what you're trying to address and how you're trying to address it. Because without their support, nothing's really going to materially change. I also think when you talk with your colleagues around it about it, it's really about doing the 80% well. We have a saying that corner cases cloud cognition, and we have have so many exceptions that they never want to even do the baseline items. And so I think those are two things within the executive level and the middle level. For my colleagues in other organizations, it's interesting because when I explain what we are like, they kind of look at me funny and say, well, how do you sleep at night? Or how do you do that? This is weird. You can't get anything done. It's a much more different balancing. So if you actually have a more structured organization where you're able to have those communication lines open with your leadership and your researchers, discuss why you want to do something and how it's going to benefit them, how you're going to make something more easy for them so they don't have I don't have to hide devices that I bring into the network from you because I think you're going to make me stop using them or something. That's the sort of thing where I would approach the conversation with them as what's in it for them, and then also show the balance, because a lot of times we talk about breaches and risk. The people our faculty listen to are the other faculty. We could talk all day long about how you need to do the security stuff. They don't care, but if it hits a colleague and they know and they've lost data because it was corrupted or deleted or removed and there was, of course, no backup, or something where it took the availability of their systems offline, they tend to listen quite a bit, right? And they start to understand that there's a larger threat than just them. They're in a house, and it's not just their room being attacked, it's the entire house or the entire building. And so I look at other organizations of what is your structure and your ability to communicate both upwards and downwards within your organization to get the message out of why you want to do this and what specific risks you're going to be able to address with this.
And let me also flip back to Barclay and Brooks a little bit as well. If you were to sell this, and I mean, it's persuade in that sense, because you're not actually, and this is all open source that you guys have put online and everything. Well, how would you frame this as to our community here in terms of some of the benefits for this to persuade them and perhaps help them persuade their colleagues of the value of doing this? I think as security people, we understand the statistics. We can say, we've cut lateral movement by 90%. We've eliminated Wi-Fi baby monitors running botnets, whatever they happen to be. But how do you make it resonate with a broader audience?
All right. Well, so it helps to have, CIO buy-in or whatnot. But I think it was Schneier that said something along the lines of security has no return on investment. It only has, and I think he backronym wedged it into Enron, which is exponentially negative return on investment, right? It's loss prevention. So if you're talking with someone that deals with a different universe, right? Like you're dealing with your CFO rather than your CIO, right? If you can map it to something about loss prevention, that helps. I was fortunate to have a supportive CIO.
No, I do wonder, and then I'll let Brooke speak. Perhaps if you're even just talking to executives, if you convince executives to say, okay, you're going to use a Chromebook and you're going to VPN through this tunnel, then you're going to set the example for the rest of the organization. And in doing so, you're going to be able to cut your IT budget by whatever, because we're not going to be patching as many viruses on all of the Windows systems or something to that effect. That seems like it could trickle down from there.
I believe we still have. We used to have a policy that all devices in or out of China were wiped. You can read about Aurora on Wikipedia. But it's really nice when you give a Chromebook to an exec and they don't care. They don't even know if it's been wiped, right? All their stuff is still there, right, in the cloud. So yeah, that provides a really compelling use case that you can just, if I'm out at this conference and I drop my laptop and it broke, I could just run out to Best Buy and spend $200 and I'm still ready to go. So.
Absolutely. Brooks?
Yeah, you bet. Getting that executive buy-in, if you will, especially with devices that are very consumerized, is absolutely what allowed us to move really fast. I would also say just driving towards what it's going to mean to use a consumerized device versus what it's going to mean to use a very specialized device in terms of cost and engineering to make those devices work. That was pretty obvious to us, and I think that's really where we saw a lot of both savings as well as in terms of money as well as time. But yeah, without a doubt, getting those very consumerized devices into the hands of executives and getting them to be the example for our organizations really helped us move fast.
Are we at the point where having general purpose devices on as many desks as we currently do is a little bit like driving without seatbelts? Are we going towards a place where you should be signing a safety waiver if you really need something other than one of these simplified devices?
Well, I don't even know if it's just that. It's like driving a really much more expensive car than you can afford.
Okay.
In many ways too, right? So you're talking about the value proposition, and it's a tough one to have in the public sector too, because we have really strapped budgets as well, and we want to maximize those for teacher and student benefit. So we have to, in terms of security, we constantly have to remind people this is necessary to protect our students and our teachers. But to your point about consumer devices, you have a lot of cost savings there, right? The system. Someone said getting away from systems management. That's like a holy grail, because that's a time suck either that or it's a money suck, right? I mean, how much licensing are you paying for something like SCCM or Jamf or all those other products to manage a bunch of systems just to make sure that they act the way they're supposed to act, versus a system that either is embedded with systems management like Chromebooks or has a minimal management footprint like an iOS device. It makes a lot of sense to me. So those factors can be arguments towards the kind of zero trust model with showing cost benefit analysis, right? So you're reducing the ongoing licensing, the perpetual licensing, and that come with systems management, will come with antivirus products, that come with your endpoint security. It totally makes sense to me.
I will recognize too that there's certain things that just have not been cloudified. Google makes hardware, right? So we have a whole bunch of place and route design software for designing ICs and things like that. Those things were written 20 years ago.
Yeah.
They only run on Windows. They might have a hardware license key, right? So there are these cases. We've sort of done what we call a narrowband VPN, where we'll use the authorization procedures we've set up to allow that VPN to open, and it can only egress to a very specific contained place that is hard to move laterally from. But there are those exceptions that you'll run into.
Other questions from the audience about how you envision this deployment might work in your own environments? Yes. Microphone coming.
Hello? All right. Nathan from the Kalinga Huron Library. And what we see is that we have, probably one of our branches, we have 40 computers. We made it a big deal. Let's get these, quad cores, 8 gigs of memory so that we could do all these things. And then from a system approach down to us, it was, oh yeah, well, hold on. We don't trust any of these things at all. So you can't install any software because we don't trust the individual software. But hold on, is it the software you don't trust, or is it Windows that you don't trust? Because if I have a little stick and I put Netflix in, I mean, what precedence does that set is basically what I'm saying is, hey, we don't trust this box, but is it the box or is it application that we don't trust? And is it how we're using it? And at a library level, it becomes an issue because everyone comes in and we come to these conferences and they always say we want to expand our horizon, we want to expand our access, we want to expand all these different things. But then when you take it to system and you tell them that you want to do these things, they say, oh, this is insecure, we shouldn't do that. And so, but I know that, heck, if someone was going to bring an Xbox in and plug in their Xbox, and maybe use Netflix to get on that, or maybe to use a little device, an Internet of All Things device, then hey, that might not be a big deal. But if it's on a Windows box, it's like, no, you can't do that because it's insecure. So I just want to point out that there's an interesting thing about where the application resides at, whether or not we trust it. So if you guys had any comments on that, because I'm actually trying to open up all kinds of things, but it's usually a thing of security. And I'm interested in this zero trust type of deal, how you could apply that on an individual application basis, or whether it just be provided to the box, or how do you make that work?
That observation is actually one of the factors that led us to tiered access, right? Because if you say the OS is patched at current revs, that's a strong sign, but it doesn't mean that there's not malware on there, right? At like an application level. But the other direction is if there's malware and it hasn't been patched, right? And you can trace that down, like hopefully you get to something in the ideal state where you have a trusted boot with like remote attestation as to the image that machine started from and build up from there. But that's like the optimal case, right? So realizing that there's different attack vectors and there's different levels of risk for different types of behaviors, like inserting a USB stick, is what led us to a graduated level of access.
So I actually just have a really quick question for you guys. Is, when it comes to financing and these models, has anybody done an analysis of how much you've saved in terms of cap expense, or how much that cap expense has been transferred into operational costs? Because a lot of these are systems of maintenance over long periods of time. Have you done the analysis there? I mean, do you have to pitch that to your CFOs or your budget people to say, yeah, you know what, we're going to probably keep ongoing costs at a constant rate, which some CFOs like, right? Because there's not that burstable capital expense. But
so I don't have any numbers, and I probably couldn't say them if I did. But I can say that the rate of growth of the number of software engineers that we hire versus the rate of growth of the number of SREs that we hire, right? Software engineering, we're hiring a lot more than SREs. And SREs are what run and maintain a lot of this with some SWEs developing it. But those are diverging. So we have to be able to scale it sublinearly to that growth, which means there's an indication that it's worth it because we have all these more productive SWEs.
yeah.
And with that, I'd like to thank our panel. Thanks very much to Brooks from Netflix, to Barclay from Google, to Dave for coming down from San Bernardino, to David Rusting from the UC Office of the President, and to Michael Liang from San Francisco Public Library. Thank you.
Thank you. Awesome.